Hi everybody, and thanks for your interest on the light animation. You wanted to see a technical rundown. Well, basically, it was a wall, of course, and we had a window here. And the idea was that inside the house, there's a couch over here, and we wanted a sunlight animation that's going to be hitting the couch like this. Like with all sun animations, you need to do two things. You need to have color, and you need to have, so it goes from warmer to cooler, and obviously there has to be some shadow movement, right? So we achieved this by putting a 20K down here on a dimmer, and then we lit it into multiple C100 reflectors, and then we went ahead and we panned the light source up from the bottom reflector to the top reflector to create the movement of the sun. And we did also on the dimmer from, I don't know how much it was, 0% all the way to 100. You could also add a frame in here if you would want to, if you would even want to have it cooler, because by using diffusion number 3 up here, you won't see the bumps from one reflector into the next, and you could even add, I don't know what it is, a quarter CTB or a half CTB, whatever you want to do, to even help in here. And additionally, we had on the inside, we had some practicals that were also in dimmer, and of course, when the sun came up, we turned those practicals off. Now, if you're interested in how this actually physically plays off, that you actually can pull off this kind of a performance process with the CRLS Precision Reflectors, we can dive in and geek out on this as well. So if we want to have a look at why panning a light source over a reflector creates a movement in light, there has to be a huge shout out to Sebastian Thaler. We shot 7500 together with, and we had to do a poor man's process, but looking at the plane, it wasn't possible to not see any lights moving around. So we came up with this idea, and it originally came from Sebastian, actually to pan a light source over a reflector to create a movement in light. So how is this even possible? It's actually really simple. If you have a light source here, right, and we say we're going to pan it from left to right. So let's start here on the left-hand side. We're going to be panning this, we're going to be more precise now, with 45 degrees into the reflector. The trick really is that the ingoing angle always equals the outgoing angle of the light source, and that's the reason we can pull this off. And then to the other side, we did exactly the same. So let's say we pan, like we said, from left to right. So the right-hand side, let's say we do another 45 degrees here, boom, the light coming out over here. So what happens here automatically, what you can see is, because by panning a light source, you are shifting the angle, the ingoing to the outgoing light from orange to blue in this way, you create different shadows. So what happens when you now, for example, have a face over here seen from the top with the nose, is that the shadow of the, for example, let's say from the blue side, would be coming in 45 degree in this angle. But on the other hand, if you then are using the other side, the orange side, you get the shadow exactly in the opposite direction. So this is really cool. And just by panning the light source, you can get it in different ways. And if you're asking why this works, this is actually real simple. We talk a lot about this. It has everything to do with the virtual light source. So what does that mean? A light source going into the reflector, like looking into a mirror, has the same distance on the other side, but is virtually basically moved, right? So in this case, it would mean virtually the light source is somewhat over here, right? So from this perspective, standing over here, it looks like it's behind the reflector over here on the other side. And the same thing would be if we now do the same thing with the blue. So virtually our light source is moving, right? Fantastic. So it would be over here as well, but by panning the light source and you're getting always the outgoing angle, again standing from this perspective, looking up, it will look like the light source is way back here behind the reflector. So what we're doing is we're actually shifting the angle of the outgoing light so it feels like it's coming from the other side, and that's the reason it looks like the light source is moving, which it virtually is, and that's the reason we have the shadow movement over here. So this is the big thing when it comes to the angles, right? Now there's one other thing we have to look at. This is number 2, the distance. Of course, it's a big difference if you have a reflector over here and you place a light source over here and we say we reflect again in our 45 degree in this direction or the 45 degree in this direction. We see a big difference in, again, the way our virtually our light source has moved. But just think about now if this reflector would be all the way up here. You couldn't actually pan the light source as far. So if we would say here, it would be all the way up to here, and then coming down here, boom, like this. And the other angle here would be boom, like this. And what you see here is that even if we had here our 45 degree angles, up here it's not possible anymore. This is going to be a real steep angle that's coming down 80 degrees or something, whatever this is here. So that means our light source just can't move as far anymore from left to right if it's far away. So that means the closer the light source is to the reflector, the better the result would be when it comes to the light source moving, just because you have more distance. So this is really important. So in the case of what we did with Sebastian, we had our reflectors here and we just placed the moving source here, and then we just panned it all away from one direction to the other one to create this movement of light on 7500. There's a third thing now we need to look at that's really important, and that is if you have, let's say, a reflector here, and then we have another reflector over here in a different angle, which you'll need like with the light animation. Again, we have a light source that is panning from left to right. What's going to happen here is it's really dangerous. You're going to have a light jump here. The reason is clear that when you, for example, have a diffusion number 0 and you go in with a light source, say from one angle, and it goes out like this, and then let's say we pan the light source over to here, and then all of a sudden you get a different angle, you're going to get two different pools of light because the light source virtually feels like it's moving. But if you go, for example, to a diffusion number 3, which in this case I highly recommend, to not have any bumps from one reflector to another one, what's happening here is that when you have a light source and it's hitting in and it's coming out, and then you pan over here to get a different angle with a different outgoing light. With diffusion number 3, you know, you have a lot of spread already just because of the level of diffusion. So it's going to be mixing a little bit better, which means at the end that your bump will be hidden by the level of diffusion because you just have a big enough spread, so you have a big enough pool of light, so you won't feel the difference anymore. So it's really important to only use diffusion number 3 because this bump will be visible from diff 0 to diff 2. And then with diffusion 3 it works, and diffusion 4 is already so soft you won't have any light animation anymore because we need this precision of the reflected light coming out of here to actually make this work. Okay, I hope this explains the process behind it and how to get that poor man's process. I hope you get to try this yourself soon, because it's really awesome how slow you can pan the light sources to get really different movements of light. Okay, all this for that. I hope that helps. Let me know if any other questions come up about the CRLS Precision Reflectors. Always happy to explain it.